Right, today's lesson is about different measurements and density that we use, measurements that we use in chemistry and density. Before we begin that, just some vocabulary from this chapter is the difference between accuracy and precision. Kind of in day-to-day life we use those words interchangeably, but actually in chemistry they mean something kind of different from one another. If you're accurate, that means you're really close to the true measurement of that item. For example, if you were weighing something that really weighed 200 grams and you put it on a scale and it said 198, then you are close to being accurate, but not exactly accurate because it is really 200 grams. So accuracy is how close you are to the true measurement value. Precision, on the other hand, is more of how well you are reproducing your results. For example, if I keep measuring that object with that same scale, I may be getting the same measurement, 198, 198, 198, and that's being precise. So when we do labs, we would really like to have precision and accuracy, and the best way to do that is to try to always use the same instruments. So if you're measuring something, don't be switching scales, etc. So the next little slide I think shows really well, in my opinion, kind of the difference between the two. So if you're throwing darts, and if you throw darts like me, you're kind of like this. You're kind of like all over the place. So this is not being accurate or precise because I'm kind of like all over the place with my measurements or my darts. Here I'm hitting about the same spot every time, not exactly the true area that I want, and that would be being accurate. So this is called precision. And if you hit the target every single time, you're precise and you're accurate. So again, precision is more a repetition, and accurate is getting that true value. So we're just going to skip through these first few. I have uploaded this PowerPoint, so this is just talking about the system that we use now, which is called the International System, and we call it SI. It is called SI because it is from French, and I don't speak French, so I'm going to let you say that. Le Système International, we call it the SI system. So it's not just the metric, it has the metric and other parts to it. So we don't use the feet and the inches and stuff like here in the United States. In science, we use the SI system, the international system. In fact, I like this little map. This shows the country and a few other little spots that still use the old English system. So here's the vocabulary if you want to pause and jot this down. Mass is the amount of matter in an object. Of course, we use a scale to measure mass, and in chemistry, we'll be measuring our mass in grams. Volume is how much space that object takes up. If you're measuring a solid, a normal shaped object, you could do length times width times height if you had a cube, and we would get centimeters cubed because you do length times width times height. So we'll be looking at some problems where you'll have the length, width, and height. To get the volume, you just multiply those. If you have a solid strange object, then you could put that strange object in a set volume in a graduated cylinder. And so, for instance, first off, to measure a liquid, we use a graduated cylinder, and we usually measure in milliliters. But this is saying 7 milliliters for this liquid, this pink liquid that's in here, and I've got this weird shaped object, and if I put that in, it's going to raise that water up, and it raises it up to 9, so it displays a value of 2. We say it's 2 centimeters cubed because it is a solid object. We usually use centimeters cubed for solid objects and milliliters for liquid. But that's not always the case. They are equal to one another because a centimeter cubed object will displace 1 milliliter of a liquid. And you might have heard nurses say 10 cc's. That stands for cubic centimeters. That's just 10 milliliters. So a cc, a centimeter cubed, milliliter, all the same thing. So another vocabulary is a meniscus. When we put, especially water's really bad about it, when we put liquid in a graduated cylinder, They do make a curve. The very bottom of the curve here is where you want to read, and that's called the meniscus. And you want to get eye level with that meniscus. And different liquids will have different amounts. It has been calibrated in the, if it bothers you at all, in the graduated cylinder, so it is taking account for this little bit of that is up there. So you do always want to get eye level there with that and read the meniscus. Oh, there's the Bible. And this is a good showing you that if you get eye level, you'll get the correct. If you are short like me and you're looking up, you're going to get a higher than normal reading. And if you're really tall, like most of you probably, and you look down on it, you're going to get a low reading. So bend down and get eye level and read the meniscus, the very bottom, not the top, the very bottom. So this is just reading graduated cylinders. Very easy, but some students think everything's always a 1, but you do have to watch your readings, and so please be careful of that in lab because it's not always. So to figure out how much each line is worth, you subtract the two values you see. So 50 minus 40, of course, is 10. And then if we count the little lines, most of the time there are 10. Sometimes there's only 5. So this is 10 lines. So in this graduated cylinder, each one is 1. Of course, this is reading up. Be careful because we'll be looking at burettes and stuff, and they actually read down. So you have to be careful and see which way your numbers are going. So this is going up, and so this is 45, 46, 47, 48. So this is 48 milliliters because we're in a graduated cylinder. If we look here, this one is 27, this one is 26. It's only a difference of 1. There are still 10 lines separating those. So each one is a tenth. So this is going to be 26. There's 0.5, 0.6, 0.7. So you just have to be careful. This is one that usually gets students here. The difference here is 5. There are still 10 lines. So each one is a half, or 0.5. So this would be 10.5, and that would be 11 milliliters. And there are some of our little graduated cylinders that are like that. So be careful and look at your graduated cylinder and see what each line is measuring. All right, then density. Definition of density is how much mass is spread out over a given volume. So the formula is mass divided by volume as a proportion. It is the reason why things sink and float. If you put two objects together, or I should say two liquids or something in a liquid that have different densities, they will separate from one another and the less dense will go to the top. Most thing we compare density of water. So the density of water is 1 gram per milliliter. Anything more than that will sink in the water. Anything less than that will float in the water. And then I don't want to insult you, but this is a cool little thing that I learned. Of course, I taught high school and actually started out student teaching at middle school. And this is called a triangle, and it helps you manipulate this formula. Not that you need it for this little simple thing, but it's just going to make these problems really super, super fast. And so we're going to put the mass on top, the density, and the volume on bottom. That is a multiplication sign. And so the way a triangle works, if you do not know, is you cover up what you're looking for. So if we're looking for density, it is the mass divided by the volume. If you're looking for the volume, you take the mass and you divide by the density. And if you're looking for the mass, you take the density times volume. And I know you can manipulate that formula, and it wouldn't probably bother any of you to do that. This is just going to be a real quick tool. I had a student many years ago that made up this little silly saying for this, and it was mountains over Death Valley. To remember that the M is on top and the dV is on bottom. So kind of cool, kind of easy, and density problems are super easy. So I will say the density is kind of the most important, so we're going to have to watch the density units, which is where we're heading with the next one. Okay, it says what is the density of an object? So we are looking for density that has a mass of 456 grams and a volume of 225 centimeters cubed. Will it sink or float in the water? Well, we're looking for density. So density is the mass divided by the volume. And I would like you to show your formula, plug in an answer with units. You're going to see that I'm really, really picky on units. So if you don't want a 99 or 98, put those units. So there's my formula, there's my plug-in, and then my answer is just simply of those dividing. So the calculator gives me this and some repeating numbers, but we're going to practice significant digits. This one has 3. That one has 3. We are dividing, so our answer should have 3. So we're going to say, well, we want you, and we want you. But we are going to take that and we are going to round 2.03. And the unit, neither one of these cancel out, so it's going to be grams per centimeter cubed. And density has 2 units. So it will always be grams per milliliter, gram per centimeter cubed. If we're talking about solids or liquids, later when we do gases, they will be grams per liter. Will it sink or float? Well, it has a density of 2. Water has a density of 1. This thing is going to sink. And it is probably a solid since it says centimeters cubed. Alright, what volume? So if we think of our little mountains over Death Valley, volume equals the mass divided by the density. So volume equals. So now if I read, here's my density. Density's good. It says I want grams per milliliter. Do you see this? That thing says kilograms. Is kilograms in that density? It is not. And so these units are not going to cancel. One way we could do is dimensional analysis, but I find the density problems are just kind of easier to just do them as long as we look at the density and go, okay, he says grams, it says milliliters. I need grams and I need milliliters. I don't need kilograms. So for now, I would like you guys to show the conversion. So we're going to bring kilograms down, grams to the top. What's bigger, a kilogram or a gram? A kilogram is larger, and there are 1,000 grams in a kilogram, and I do want you to memorize that. So that is 36,000. We won't worry about sig digs because we're not at the end. Okay, so there's my mass, 36,000 grams. That is one heavy object, and it has a density of 0.865 gram per milliliter. So here's what I wanted you to see. See those canceling out? And that's the unit we're going to be left with there. So our answer, according to the calculator, is 41618. But hold on, we want to talk sig digs. We want to talk sig digs of the original problem, not of our conversion. Okay? Not of the conversion, of our original. That one had 3. This one also has 3. So we are going to round this answer to. There's 2 ways you can do it. I go 1, 2, 3. That's not a 5. So now these can become zeros. Okay. Or you could put it in scientific notation. Yep, that's right. 1, 2, 3, 4. Which one do I prefer? I really do not care. My brain likes both. Your brain might not like both, but my brain does like both. When I want it in scientific, if it has more than 4 zeros, I don't want to count all those zeros. Okay, notice that. Will it sink or float? Most students say, oh my goodness, it's 41,600. This thing is definitely going to sink. Nope, this thing is going to float. Why? Why is it going to float? Because of this density. The density determines whether or not an object sinks or floats, not the volume. That's why ships can float. Okay, it has to do with their buoyancy, their density as well. So, okay. Last one. Okay. It says, what is the mass? Mass. Whoopsies. My thing will do that sometime. Let's see if I can do an undo. It doesn't like M sometimes. Alright, our mass is density times volume. So mass equals, density says 2.98 gram per milliliter. It says I want gram. Okay. I want milliliter. Okay. I have been given not milliliter. I have been given liter. Guess what? Going to have to convert it. Where am I converting it? I'm converting it to, you got it, milliliters. Which one is bigger, a liter or a milliliter? A liter. There are 1,000. So this will cancel, and that will get us 550 milliliters. Not worried about sig jigs until the end. Gotta multiply. 550 milliliters. Now you can see those guys canceling, being left with grams. So the calculator gave me 1639. We know it's going to be grams. We're going to look at sig digs, or sig figs, whichever. There are 3 here. There are 3 there. Miss Beth, you telling me you kind of like 3? I kind of like 3. Kind of like 3. You will see 3 a lot, but that's okay. There are 3 here. There are 3 here. Guess how many we need? We need 3. So we are going to round this. You can do it 2 ways. There's a 3. Oh, that's a 9. So we can round it to 1640, or 1.64 times 10 to the 123 third power grams. Ta-da! Sink or float? Well, it has a density of 2.98. This thing will sink. All right, that's it. That's density.